Now let's do one example. Here we have a gearbox and it is at steady state. On top we have a big gear and we have 60 kilowatts going in. And then at the bottom you have a small gear. We have 58.8 kilowatts comes out of it. What a gearbox does is to change the angular velocity. That's what it does. So 60 kilowatts goes in, 58.8 kilowatts comes out, which is not ideal because if I have 60 coming in, I want to have 60 coming out. However, there's only 58.8 kilowatts coming out of it. So where is the loss? I've lost 60 minus 58.8, which is 1.2 kilowatts. Where does the 1.2 kilowatts go? Yes, the gearbox is very hot, so inevitably you're going to lose energy to the environment by heat transfer. And how much do you have to lose? According to conservation of energy, you are going to lose 1.2 kilowatts, and that is your heat transfer rate, right? Because the unit is watts, so that's rate. If it is kilojoule, that will be heat transfer Q without dot. Okay, so this is how much heat you have to lose to the environment, 1.2 kilowatts. So now you can see the energy balance is satisfied. Total energy going in is 60, and total energy leaving is 1.2 plus 58.8 equal to 60. So 60 goes in and 60 comes out. So now energy conservation is correct. Okay, and don't forget we're looking for sigma dot. The name of sigma dot is entropy production rate, how quickly entropy is produced. And then from the number you can tell if the process is reversible or irreversible. Okay, so now we're going to start from entropy rate balance equation because that's the only equation we have that has sigma dot in it. So we're going to copy this equation. Left hand side is d capital S over dt. Right hand side is sigma q dot j from tbj. J starts from 1 and ends at n. N is the total number of surfaces we have. What is the total number of surfaces we have? We have the top surface, which we can call number 1. We have the right surface, which we can call number 2. Bottom surface, number 3, and left surface, number 4. So we have 4 in total. We end at 4. Second term plus sigma dot. Okay, so now this is the entropy rate balance equation. And then we tell you the whole system is at steady state. Steady state means no properties change over time. What is my left hand side? My left hand side is entropy change over time. And we know entropy is a property. So left hand side must go to 0 because there's no change over time. So the change over time must be 0. Okay, so now we can rewrite this equation. Sigma dot will just be equal to negative sigma j from 1 to 4 q dot j over tbj. Okay, let's continue. The first term will be q dot 1 over tb1. Second one is q dot 2 over tb2 plus q dot 3 over tb3 plus q dot 4 over tb4. 4 terms in total. And now what do we know about tb? TB is constant. TB is given as 300K. So TB1 is equal to TB2, equal to TB3, equal to TB4, and equal to 300K. So they have the same denominator. So left hand side just becomes TB, and it becomes Q dot 1 plus Q dot 2 plus Q dot 3 plus Q dot 4. What is Q dot 1? Q dot 1 is the heat loss on surface 1. Q dot 2 is the heat loss on surface 2. And Q dot 3 is the heat loss on surface 3. Q dot 4 is the heat loss on surface 4. So what is that in total? Just negative Q dot over TB. And Q dot is the total heat loss for the whole system. Okay, so now let's take a look. Do we have a Q dot? What is the total heat loss to the environment? the total heat loss from the system to the environment is 1.2 kilowatts right here. We solved it already. It's 1.2 kilowatts. So now, before you plug in this number, make sure you understand this is the heat leaving your system. If your system loses heat, you should plug in a negative number. So we plug in negative 1.2 kilowatts. Okay, and I'll make a note here so you don't forget. Plug in negative 1.2 megawatts. Okay, and the next one, denominator TB is given as 300 Kelvin, which is SI unit. That is great. So now you can use your calculator. Our solution is positive 4 times 10 to negative 3 kilowatts per Kelvin. And that is the solution to sigma dot entropy production rate. Okay, so now we're done with looking for sigma dot. So next one is, can you tell me if this process is reversible or irreversible? Because our solution for sigma dot is greater than 0, that means it must be irreversible. What if our solution is equal to 0? That means your system will be reversible. What if our solution for sigma dot is less than 0? That means your system is wrong. It's impossible. It will not happen because your design violates second law.